Okay, so I see there's no real other questions that somebody has yet to do. So while I'm waiting for some of the questions, let's just have a general look on the training page here quickly. Okay, installation requirements that we or that one of this training document is put together by me, and I recommend certain sizes of breakers for certain reasons. And on this page, on installing this unit, I recommend that you have a 25 amp input breaker always, and a 20 amp to 25 amp output breaker. I usually recommend a 20 amp output breaker. Reason being for this is that you can never overload my unit on a 20 amp output breaker. So that means you can never overload it, and the breaker will trip before the inverter trips. A breaker is a much cheaper component than the whole inverter. You lose about 200 to 300 watts of your maximum power. So the inverter, if you put a 20 amp output breaker, will trip roughly at 4.7 to 4.8 kilowatts, depending on the breakout sensitivities. So that's why I put a 20 amp output breaker, because let's say you're pulling 5.5 to 6 kilowatts through this machine, it can do it. It will bypass that current, and ESCOM fails at that moment. Then your machine will immediately go into a over current alarm. So then you're overpowering the inverter and it will trip. And if you do that a few times, it will be seen as abuse on the inverter, and your warranty will not cover it if you keep on overpowering your inverter. So that's why I say with a 20 amp output breaker, you know you won't overpower or overcurrent this inverter. So you're always safe on this side. Then we recommend you have an SPD also on the input side. And then earth leakage as well for your, if you divide your DV board into essentials or non-essentials. And then just lights to show if the grid and inverter, which one is active at the moment. That's just for safety. And then a changeover switch. It's very important to wire in a changeover switch, especially when you start to do updates. Once you start to update these machines with certain updates, the EPS power will be cut. That means that the machine won't provide power to your essential loads anymore. So your Wi-Fi and stuff like that won't stay on, and the update won't be complete, and then you'll sit without power. Now, if you have a changeover, you quickly change over everything to ESCOM, so you're bypassing the inverter so that everything stays on during the time period of the update. So it's very important. Please install changeover switches. It's not a very expensive thing to do. It just makes the whole installation quite easy to do when you have to update an inverter. So that's on the AC side. Then I see I have a question before I move to the DC side. If there's any questions on the AC side, you can also ask there. Let me quickly see. I have 2 messages here. Okay. No, I don't really know the names of the prepaid meters that don't trip. I know some of the meters is less sensitive. I can't give you brand names. I'm not sure. But I know there's some meters that's not that sensitive. If there's anybody here that maybe knows about a meter, feel free to comment the name of the meter or type of meter that's not so sensitive. That would be nice. But unfortunately, no. I don't know about any meter that I can give you a solid answer on. Okay, Morris, I see what you mean there. On my side, I haven't heard of anybody that specifically told me about this. I'll definitely give this through to the R&D team, the guys that is highly qualified with this type of electronics, and then ask them the specific question to hear what's their feeling about it. I haven't had any of the guys that's complaining. And on this topic that you said of the bigger breaker, For me, I'm not sure if that's a valid reason, because any type of breaker, once you break it, it should have the same effect. If it's a small or big breaker, once you break it, it breaks. So I can't see why. I could be wrong, but I can't see why this would have an influence. Then this should be, yeah, I'm not sure why this could be, but yeah, let me find out for you. I'll definitely ask the R&D team, the guys that has a very big engineering qualification and stuff like that in electronics, and hear their opinion. Maybe it could be right, but I don't believe that it can have any effect. So let me just quickly ask them, and I'll get back to you on that one. So what is the best way to? Okay, neutral earth bonding. This is a very common question that we get at this moment. A lot of the machines don't bond the neutral and earth. They use the neutral earth bond that is supplied by Eskom side. The thing that we do in a lot of these cases is we install a normally open or a normally closed. Depends on how yours work, but I recommend a normally closed contactor. Can be a 5, 10, 15, 20 amp small DIN rail contactor that you wire into your ACDB box, that the contactor gets its power from the Eskom side of your AC box. Meaning as long as Eskom is there, your normally closed contact will be open, because the coil is getting power, so it's opening the neutral earth bond. And then as soon as Eskom falls away, your contactor will close and create an artificial neutral earth bond. Then as soon as Eskom is back, the inverter will reuse Eskom, and then your neutral earth bond that you created will open again. So then the contactor will open, and then your bond is on Eskom side. So then it's not necessary for the neutral earth bond again. So that's what we usually do on this system. So you just put in a normally closed contactor that opens with Eskom power and then close as soon as it's load shedding or the power fails. I hope that answers your question. I see I have another message. If the contactor fails in an no, you won't do any damage if you have a permanent bond that you create. It won't damage anything, but it's not technically allowed to create a permanent artificial bond, because it should be bonded at the transformer at Eskom side. But it won't damage anything now. It's just not technically correct to have a permanent bond. So you can definitely use it like that. If it fails and the contactor stays open, or let's say this contactor stays closed and your bonding is done by the contactor, nothing will blow up or anything. And if your contactor stays open, then you have a floating neutral that will cause that your earth leakage and stuff like that won't function correct. So it's better for it to fail in the closed position than to fail in the open position. But the contactors is not something that really fails a lot. But yeah, it won't do any damage. So you can just regularly check if it is open or closed just to make sure it works. But the contactor is not something that really is going to give you a headache. So that's on that one. Okay, this specific inverter, the SNA 5000, is not a hybrid inverter. It's an off-grid inverter that has hybrid function. As you said here in the questions, can it be used as a fully function hybrid type? No, it can't really. Reason being is this inverter does not have a CT clamp. As soon as you don't have a CT clamp, you can't limit your backfeeding to your non-essential side. This inverter has the capabilities to backfeed and to use Eskom and PV jointly. That's the hybrid function. That's what's called an eco hybrid, because it has some of the hybrid functions. But because it doesn't have a CT, you can't tell this inverter only to provide the excess panel power to the non-essential side. Let's say like your geyser or your swimming pool pump or whatever is on the non-essential side of your DV board. You can't limit it to say the non-essential side is only pulling 500 watts. So you're only going to give 500 watts to the non-essential side. If you enable the hybrid function on this inverter and you tell this inverter it may backfeed, then it will backfeed all available power that you give it. Let's say your panels can produce 5 kilowatts worth of power on the roof, and you tell this inverter you may backfeed 100%, then it will backfeed 5 kilowatts worth of power to the grid, even if your non-essential load is only taking 500 watts. So that's why this inverter is not a fully hybrid inverter. If you'd like a fully hybrid inverter with a CT clamp and all of that fancy stuff, then you can have a look at our LXP 5K. I just typed the name there, the LXP 5K Luxpower. That's a fully hybrid inverter, NRS approved, all of that goodies. So that's our fully hybrid inverter. This is our answer to Daya and all of them is the LXP. And then the SNA 5000, the inverter, that's the most common one that we sell at this moment, is a replacement that we would like to replace the market for all your Voltronics and your expert boards. So like all your smaller type of off-grid inverters, this is the answer that we have for their units. We would like to use this unit in South Africa as an off-grid unit rather than the expert boards. The reliability of this specific unit is much higher at this moment. We have an extremely low return rate at this moment. So we are fairly happy with this unit. If solar side of the inverter is faulty, can the invert? Yes, if your MPPT board is broken, the inverter will still use the battery power to provide load. Then you're just going to struggle to charge your batteries. Then you're going to have to see if the main board's allowed to AC to charge the batteries. But usually when something like your MPPT gets damaged, then you can use it as a backup unit with Eskom charging the batteries and supplying the load and all of that stuff. So it will still function with a damaged MPPT, but it's not recommended that you run it like this. As soon as you see there's any fault on your inverter, for example, you see the MPPT side, the solar side is damaged, then it's recommended immediately to take it off and bring it to one of your suppliers that can bring it to the repair center so that we can repair it or assess the damage and see if we can give you a warranty claim on it. Otherwise, you're going to damage the inverter. If something is broken in the inverter, you can't keep using it. Something else is going to get damaged. It's made to work as a whole machine, so everything needs everything to function correctly. So it's not recommended that you still use this unit if the MPPT side, the solar side is damaged. It may cause damage to the rest of the machine as well. So it's not recommended, but it will still use power from the batteries to provide load. Okay, I see that's on the questions. There's no other message that I'm seeing, so I'm just going to continue on the manual here while there's still questions coming in. On the recommendations still for installation side, we recommend that you have fuses on your positive and negative lines coming down of your strings. Then my MPPT has the capability to go up to 485 volts on the PV side, but my MPPT's working range is from 100 to 385, but from 120 upwards, the MPPT will only start really to provide power. So it's recommended, I like to keep my PV voltages between 120 and 300 or 400 volts. That's the perfect spot for the MPPTs on this machine. There is 2 MPPT separate trackers on this machines. So you can connect 3,250 watts on an MPPT. So that gives you a total of 6,500 watts on this MPPTs. Of this Luxpower, so it can handle 6.5 kilowatts worth of panels. The two MPPTs is working separately, so it is two separate MPPT trackers. So what's happening on the one string doesn't affect what's happening on the second string at all. Then from there on, SPDs on the MPPT side is recommended as well as an isolator switch, so that you can isolate your DC source coming from the roof, your panels, and then a battery disconnect box between the inverter and the batteries. We always recommend that you have a fuse system between the batteries and the inverter as well. And then cable wise, a 25 mil cable will be sufficient, but I like to use a 35 mil cable, so then you know you're always on the safer side on the battery side. That's for the basics for the installations. So this basic components is what we recommend that you use on the system. This is this, and then as well on the MPPT, just be sure that you don't go higher than 13 amps on an MPPT. So that's the ampage on the MPPT. So please keep it below the voltage and the ampage of this MPPT and the watts. So there's three parameters that you're going to have to look at: your volts, your amps, and your watts. It doesn't mean because it can take, let's say 450 volts, that you can just put 450 volts worth of panels on it. If I put 540s on it, then I'm going to have 9 540s on it. So that gives me 4.5 kilowatt. And then it's over my 3,250 watts per MPPT. And then the question that you have here on 13 amps, it is 13 amps per string. So it's 13 on the one MPPT and 13 on the second MPPT. So the two MPPTs specs are, it's not the same MPPT, so it's 13, 13. So yes, that's for the MPPT side. Then if we go to the battery compatibility list, we can have a look at the battery compatibility list here. Okay, first, before on the battery side, we have a very big not miscommunication side on the cable side, if I can put it like this. There's the words I'm looking for. On our cable, Luxpower uses a crossover communication cable for CAN communication with most of your batteries. You can have a look on most of your batteries. You'll see that on the battery side, that CAN H and CAN L is 4 and 5 on the pin side. So on the inverter side, is it 3 and 4 is my CAN L and CAN H side. So if you have a battery that you'd like to make so it can communicate, then you're going to have to make yourself one of these cables. Most of your providers makes this cables for you, or you can create your own. But it's very important that you have this specific battery communication cable set for you. Then as well as the battery compatibility list, I'll throw that list on the screen now as well, so that you can have a look at which batteries is compatible with the Luxpower. That's also very important. So I'm going to quickly get that list for you now, and then I'm also going to screen share. Did you just give me a second there? Okay. Screen. Okay. Okay, here's my battery compatibility list. So for this specific list, you'll see Pylon Tech is one of the batteries that's fairly working nice with the Luxpowers at the moment. Dynas batteries is personally one of my favorite batteries to work with Luxpower at this moment. So I like a Dynas battery extremely with the Luxpower. They work very nice together. So does the Pylon Tech and your Dynas. some of the batteries that you can use. Shoto at this moment also works very well with the Luxpower inverter, but you're going to have to ask the guy that you buy the Shoto battery from to change the protocol on the battery's BMS to Luxpower. I'm having here and there some of the problems with the Shoto's pylon tech protocol between the Luxpower and the Shoto. Once you transfer it to the Luxpower protocol on the Shoto's BMS, then a Shoto works very, very well with the Luxpower without any problems at this moment. Then the other battery that also fairly works well at the moment with the Luxpower is your Hubbles. Hubbles also works very well with your batteries at this moment. And then from there on, the batteries that's not on this list, Solar MD's batteries at the moment, we have them, working with them, Lithium SA. I believe they are compatible. Soon of one of these days, they will also be compatible. Then Freedom One, we are working with Freedom One at this moment as well. So hopefully one of these days, Freedom One will also be compatible with the Luxpowers. They're working with it. We are trying to see if we can work with BSL at this moment to see if we can get BSL and Luxpower to communicate perfectly. And then one battery that works very well is the Batridge or Greenridge battery. It's the same company, just two different names for the batteries. The Batridge Greenridge battery also works very well with the Luxpower at this moment. So that's that. I'm just quickly going to go back to the added training manual. Let's go back to this one there. Then the next thing that I'm going to show you guys is the online monitoring platform. So before that, I would just like to let me just quickly see. I have a few questions before I move on here. Rainy day with sun shining. With the question that you have at this moment, I see both questions is basically the same that I've asked there. No, the 3,500 watts for that short while, it won't really damage the MPPT on that side. For that small time value, the MPPT can definitely handle that. I'm sitting with cases of people that's abusing my MPPTs quite badly, putting panels wrong way, paralleling 3 or 4 strings down on one MPPT, and stuff like that. The MPPTs is fairly durable at this stage. So on the max flipping side and on the same question on this too, as I understand it, it won't damage the MPPTs. I have a lot of systems that runs on 14 panels and all of them are fairly happy at this moment. Yes, on a rainy day and the sun comes out behind the clouds and everything is nice and clear and nice and cold, then it will produce for that 30 seconds or so, it will produce slightly more power, but then it will come down. And that amount of power can only be produced if you pull that amount of power. So for this instance, you're going to have to run your inverter at 5 kilowatt maximum power constantly to produce that amount of power. This for the wattage is usually more on the volt side to protect the MPPTs, that your voltage will also rise in this case that you asked here about the 7 panels. So your volts on 7 of them is going to be 350 volts. So the voltage spike on that is definitely not going to damage the MPPTs, and the chance that you're going to pull 3.5 kilowatts on an MPPT is not, you can't pull that much at that moment. So both MPPTs will work together to provide a load. So you technically, you can't overpower the 2 MPPTs on that spec, except if you have one on the MPPTs, then it's possible. Let's say you only have 7 panels, then it will run slightly higher for that short while, and then it will come down again. but the MPPTs of this inverter will handle that small spike for that while and then come down without any real damage. So yes, that small spike is fine for that small while. It's going to run like that. I hope I answered that question as you'd like it. And then the maximum clipping factor we can use for the MPPTs. If I'm not mistaken, it's the same question as at the bottom. So yes, anything else on that questions that you have there? Or is everyone fine there? Then from there on, I'm just quickly going to screen share the online platform just to run through that to see if there's anybody that has a few questions about the online platform, how to monitor it, how to create the station, and how to do settings, and then of course how to update your units yourself. If you have an installer's account, you can definitely update the units yourself. You don't need us to do any updates. Okay, let me just quickly do that screen share there. Give me a second so I can just quickly go to the online platform. Okay. I presume everybody can see my screen here now. So at this moment, this is how your monitoring page is going to look. So for this instance, if you land on this page, you'll see that you have your solar panels, your batteries, and your EPS side. That's your emergency power supply side. If this inverter is working from the batteries and the panels to provide load and the hybrid function is not enabled, it's like in off-grid conditions, then you'll see your EPS power is coming from the inverter to the bottom here. As soon as your hybrid function is enabled, you'll see the orange lines running between the inverter and the pylon that shows the grid power going down to the consumption power. So that means that's the side when it uses AC and PV jointly function. That's when it's on the hybrid function to provide power to the loads. In effect, both of them are pretty much the same. Here at the bottom, we have a history graph just to show the history of what is happening on the inverter, to see what was the power at a certain point. Let's see from here on 8 o'clock in the morning where the sun starts to shine. We can see this guy, battery is charging. This guy don't want to use his batteries at all, only for load shedding. So that's why his graph runs, the grid provides the loads, and he only wants to use his batteries when it's load shedding. But in this instance, we can see what was the power that we got from the PV. So solar PV power at this stage was 1.6 kilowatts. The batteries was charging at that, in the import from the grid power was 3.5. And then the total consumption was 4,000 watts. This guy has the function of the hybrid function is enabled at this client. That's why you'll see the panels gave you 1.6 kilowatts, and only 1 kilowatt was charging the battery, and the other 500 was added to the grid power. So that he only used 4 kilowatt, but he only took 3.5 from the grid. So this guy is using the hybrid function on this SNA inverter. Then on this graph, you have the capabilities to go back a few days. Let's say I want to go back to 26th of this month. Then you can see, for instance, here you can see his production was running fairly well, and then it was load shedding at his house. That's why production is so low. But at this moment, this guy, he has maximum. He has 14,455 watt panels on his roof. He's been running this machine for almost 3 to 4 months now. And in a good day with the sun shining, he's getting an average of 5 to 5.4 kilowatts worth of power from the solar constantly on his machine. So the guy is really running this inverter to his maximum at this moment. Here we can see at the bottom a slightly less in-depth graph of what happened. So you can just see this guy exports to the grid a lot. So you can see how many solar he got for the day, what is used on his batteries, and then as well what was his consumption and how much he exported to the grid as well. Just for interest's sake, I'm just going to go back to one of his highest days so far that I found. Is one of them 41.7 kilowatts for the day. At this moment is 42.1, 41, and I believe there's one high if I'm not mistaken, and it should be this one. 42.8 kilowatts of production from the sun on a maximized SNA 5000 that he got from the sun. So basically 43 kilowatts worth of solar production. I believe that's a lot of power. That this unit, for the price that you're paying for this unit to give you 43 kilowatts, that's extreme numbers on this unit, and it's been running from with solar panels, it's been running from the 10th of the 3rd month. So it's almost, that's more than 3 months now. That's almost 4 months that this unit has been in by this client that it's been doing that. So that is on the front page that you'll get. From here on, if you are an installer, you have the capabilities to change settings. So once you're on the specific station that you were, you can go to the settings, and then from here on you can physically go do any settings that you'd like. First press the read button, then from here on you can do any settings that you like on this inverter. I'm going to have a few more settings that you're going to have on my account, but you'll still have all the basic settings at this moment. You can change the battery type on this inverter from no battery, lead acid, or lithium. Then lithium, you can, if you select lithium, you can select the brands from there on. Then from there on, you can set the nominal voltage of your batteries. The PV input, you can have the PV inputs. So on this side, you can decide if it's a DC source, a 2 MPPT connected to the same string, or 2 MPPTs connected different strings. On this unit, you have, back to the MPPT thing, you can physically parallel the 2 MPPTs. That meaning the positive and the positive of the 2 MPPTs, you can physically parallel with a wire, and the negatives as well. Then you can run this machine up to 26 amps on a string. Then you can bring down one string of your panels, and then it can handle 26 amps combined. So then the 2 MPPTs will work as one MPPT. So that's one way. If you have panels that is amperage is too high, then you can do it like this. Animated system information, could we please get okay, I see what you say there. I will definitely ask them to make a note of it and see if it's possible for us to put in the grid voltage and the PV voltage on the mobile app as well. The mobile app is more for the end user side, if I can put it like that. It works for installers, but the mobile app, I will tell the clients, the mobile app is more end users friendly than installers friendly. The online platform, as I'm showing you now on the internet, it is more internet, it's more installers friendly, the internet version that's on the browser, than the mobile version for installers. So I always tell the installers, try to use your browser one, the Luxpower login that you type into Google, and then log into your online version of the app. It works slightly better for the installers, and this is also where you can do your updates and all of that stuff. Make a parallel system and everything on the online platform. I'm also going to show you that now. So then on the application settings, this is where you can change your EPS voltage. So you can see all of this. You can do your EPS voltage changes here, frequency, generator power, maximum generator power if you'd like it. AC first, that's the time during which this inverter will only use ESCOM and not PV power or battery. But if you have selected a hybrid function, then it will use PV power as well in the AC first time. This is the hybrid function. This guy's hybrid functions is enabled, so we can definitely he can use the PV and AC jointly function and export to the grid. He still has one of the old meters that's not bothered if he exports or not. Parallel settings, quite easy. You can select single phase, three phase parallel. If it's three phase, you can select the phases per inverter. Battery shared. That's to give to tell the inverters that all of them are using the same battery bank. I always recommend that you use the same battery bank on your units because all your units isn't always charging at the same rate, or they aren't always running at the same efficiency, meaning that one inverter will always use more power than the other inverter. So if they have three individual batteries, you can have the danger of one battery running slightly down faster than the other two, and you won't get your maximum amount of power out of your battery bank in a backup situation. Where if all three batteries was connected to each other, it's one bank, and your inverters is using the same battery bank, then you'll get much more efficiency out of your system, because then all three are charging the same battery bank and all three are using the same battery bank. So then it's fairly equally divided. Charge current limit, that's the maximum charge current that the inverter will charge the batteries on. If you change that value there, then lead acid settings is the same as user defined settings. Very important. So you can basically use this user-defined settings as lead acid settings. The equalization period is not active in the machines, so you don't have to worry about this function. AC charge, at this moment, AC charge is bound to a time as well. If you put AC charge according to time, then it will charge your batteries 100% during the times that you enter to it. According to voltage or SOC is basically the same. SOC is only for when you put in the percentage. Now, if you put in a time at this moment, tell it it's from 5 o'clock till 10 o'clock at night. If my battery is between this lower than 20%, and it was charged to 100%, it will do that. But if your batteries are, let's say, for instance, at 50%, and you have entered between, let's say, 5 and 10 at night, between that two values, your machine won't use your battery power. It will use ESCOM to supply the loads. So we have asked, Luxpower is working on a extra function that we put in here, that we can have a only charge scenario for there's no time bound to it, to say for emergencies when my batteries ran down to 20% for what case it may be, and ESCOM power is back, then it will quickly charge up until the percentage that you said is the end value, and then it will switch back to the mode that you had, like SBU and so forth. So they are working on a solution for this as well. So hopefully one of these days we'll have an update to correct some of the AC charge settings that some of the clients have asked that we've inserted for them. Then generator charge type. This one you can enter according to voltage or SOC. And for the generator to be used, you're going to have to be on one of the newer firmwares. Otherwise, it won't allow you to change any of the settings to do any generator charge settings. So then you can tell the start voltage. If it drops below this voltage, it must start to charge your batteries, and the end voltage, and the same for the side. Generator start is the same for the SOC and end SOC values. Discharge values, it's very important to only use your voltages when you have lead acid settings, and very important to only use SOC, your state of charge, when you have a battery that's communicating. If your battery can't communicate, you can't use SOC values, because it's a value that is generated by a formula. So that means it is the battery takes it, you say it's 100 amp hour battery, and if it's at 52 volts, generally there will be 30% left or whatever, like that. So the system works on a formula like that. So it is not accurate if you have a lead acid setting based battery, meaning a lithium battery that can't communicate. You can't use SOC. It will never correspond with the true SOC of the battery. So always voltage settings when you use lead acid, and then SOC when it can communicate. So as soon as it can communicate the battery, then you are free to use SOC settings. Then you can use the percentages anytime. On this inverter, we also have the on-grid EOD SOC or voltage. That's the value at which the inverter will start to use Eskom power when Eskom is available. So if you put your battery, let's say at 50%, if your battery reaches 50%, your inverter will stop using the battery power and then start using Eskom power. So to make sure that you still have that last amount of battery power left in your inverter. That's what the on-grid EOD settings is for. Then the rest of the settings downwards is not applicable. So that's on the discharge settings, the charge settings. Any questions on these settings? If there's anything that you'd like to know, you can just hover above it, and the explanation of a brief explanation of the setting will appear, and then you can just have a look through that as well. So now, for instance, let's say you have a system with that's paralleled. Let's quickly go. I know this system is paralleled. So for instance, this system, you know, is a parallel system. You add both dongles underneath the same station of both inverters, and both inverters dongles needs to be on at any given time to see both inverters information. So both dongles is connected to the internet and under the same station. Then you'll see on the right hand side you have a parallel option where you just tell parallel index 1 or 2 and 1 or 2. So if there's 3 inverters, it'll be 1, 2, 3, 1, 2, 3, or if there's 4 inverters, 1, 2, 3, 4, 5, and then you just go on like that for the amount of inverters that's in parallel at this moment. Once it is paralleled your system, then you'll see a box appear with multiple inverters that is showing you the combined value that this inverter is giving at this moment. Then from there on, you'll see both inverters information here. One is charging, the SOC of the 2 inverters, batteries, P charging, the power of the EPS side. As you can see, it's fairly divided. The units fairly divide the power between of them quite nice at this moment. So they divide the power quite equally without any troubles on the newest firmwares that one has. So that's how to do a parallel system. And then the last thing on the online monitoring that I would like to show you guys is if we go to maintain. From maintain, if you have an installer's account, you will have these options on the side. Remote update. This is where you'll have the capabilities of updating your own inverters that you've installed. You don't need any help from Luxpower at all. So for instance, I know the station that I was on, so I just click the station button, then these 2 inverters appears here. To see if your inverter is on the same firmware, you can just have a look at this box that says firmware code. So you can see that firmware code needs to be exactly the same for a parallel system to work. And then if you'd like to update it because it's not the same, then you can select standard update, standard update. As soon as you select the standard update, you'll see the progress starting to run here. Once it's started, there's 3 updates on this inverter. So it's the first one, That's 70. The second one is the 63, and then 24. As of yesterday, I believe we have a new update that was released on them, and it will be still, if I'm not mistaken, it will be 24, 70, and 75 will be the new firmware version that was released. But this block here is very important, that it's the same value of the same firmware to make a parallel system work correctly. Then as well, if you click on the update record, this is where you can follow up to see if an update was done. If it failed, it will say failed, and if it was successful, it will say successful. You will only have your account's details here, so it will be easy for you to track your updates if it was done. Once an update has failed, you'll see here on the side there will always be a cancel button. So there will always be a cancel button. You just click cancel on that side, and then you run back to standard update and click standard update on the specific one again, and then it will continue where it stopped. So if it stopped on 92%, it will start at 92% and complete the last 8% of the update. So if it fails, you don't have to worry, just cancel the action on the side and reinitiate the update, and it will start where it left off. That's that on the monitoring page at this moment. From here on, I'm just quickly going to go back to the training manual to show a few stuff there that we can go on this page at this moment. We'll also share this training manual at the end of the session again with all of you. This is just how the online settings is set up. Then the parallel settings. Physically on the inverters, the communication cables is a lot of the times problems. We use normal straight pin out cables. That means pin 1 to 8 is the same on the one side than the other side. So it's a straight communication cable. Let's say, for instance, I have a system that's only 2 inverters, then it will be still the same function. Then it's from the first one to the last one, and the 2 on the inside will be bound. And then your dip switches that you see here. Your dip switches is the first inverter in the communication chain, and your last inverter in the communication chain must be on and on. Both small white dip switches on, and the ones in the middle must be off. So if it's 2 inverters, it will be running from year to year, then on, both on, both on. Then if it's 3 inverters, it will run from the first one to the third one, last one, then it will jump, and it will jump again, and then that one will go to the last one, and then the last one's dip switches on, and the first one's dip switches on, and the middle one off. The same if there's 4 inverters, it's the same principle there. Okay, dip switches, as I said, the first and the last one, it's a normal straight communication cable. And then, as I said, for the battery settings, battery shared if you have a same bank. And then if you have one bank of batteries between 2 or 3 inverters and you enable battery share, then only the master inverter should have a communication cable. It will work perfectly with only one communication cable from the master inverter to the battery, and then the master is usually the one that you switched on first. I will definitely ask them to see if we can have release notes on the firmware. I haven't worked with the release notes so far. I don't know if they have available. That's the first time question that I'm getting on that one. I'll definitely ask them if we can have that release notes. I think that will be beneficiary to all of us to see what the update is bringing in and what was fixed. I'll definitely ask them to see if we can to make it accessible to the installers as well. So I'll note that one, and then let's see if we can get that right. Then on the parallel side, you'll see 10 units in parallel maximum. All can work from the same power. All the inverters, inputs and ACs, input power and output power must be the same. So you have one input source connected to all the inverters, and one of all the inverters output source should be combined to a common bus bar as well, so that you can parallel all of them like that so they can work together. Now I'm not going to go through the codes that you can see. This page is quite nice in depth, that shows you happy face, this code, what codes means. You'll have all of this at the end of the session so that you can do your own troubleshooting as well. So that's just basically general codes that you can have a look on. Compatibility list. Okay. Now this is one of the parts that I like to explain quite nicely to the clients. This is how to get an inverter to do whatever you'd like it to do, the working modes. We don't have yet working modes that you can select SBU or UTI and so forth. You're physically going to have to change a few settings to get a working mode as you'd like it to work. Now for the inverter to use solar battery utility. So that is basically an SBU mode. So that is most common, what most of the clients would like to use: solar panel, then the batteries, and then lastly the utility source. Then setting 14 must be disabled. Setting 15 is your AC first. All time values must be set to 00. And then setting 12, your on-grid EOD must be at the desired level if you still want battery left for load shedding or unforeseen outages. And then setting 11 is your cutoff voltage or SOC that you're going to have to change. This is your basic settings. I am going to explain them on the screen now as well. If all of you can have switch to the screen that says Yaku screen at this moment, you can see there's an SNA 5000 screen on it. So if all of you can just quickly pin on that screen, then we can just quickly have a look there for you guys. Okay. I believe everybody can see the one that says Yaku screen. Now, for instance, as I said, go into the settings by keeping in the enter button. So from there on, we are in the settings because you see setting 0 there. So setting 1, we would like to start at setting 12. So setting 12 is your on-grid EOD setting. It's very important for you to set your on-grid EOD first. It must be higher than the cutoff setting. So 12 always before 11. So let's go into it. At this moment, it's set to 15% because this machine, you can set it to whatever. So let's say for this instance, my client wants a small amount of battery power left. So then he's going to select 40% for the on-grid EOD. So as soon as his batteries reaches 40%, he will have, or Eskom will take over from his loads that's available at that moment. From there on, we can go to setting 11. That's your cutoff. I usually like to use 20%. That's your own preference there. So my cutoff is set to 20% on my battery. Then number 14 is the next one that you're going to have. So AC charge. You'll see the AC charge is flickering as well as enable at the top. You want to disable this function. So you say disable. Press enter. So AC charge is disabled. Then you can go on to 15. Now 15, as I said, all P values should be double 0. So you'll see there is P1 end. The first one was P1 start. So end as well, double 0. So the same on the P2 value. So at this moment, this inverter is set to use solar battery utility. That is how you set that setting for solar battery utility. From there on, there is the next setting that I'll send as well through is solar to supply loads during daytime and battery only for backup. So this is, for instance, where you only want your battery for backup, but still want to use solar to supply all the loads during the day. For this setting, it all stays exactly the same. Your setting 14 is disabled, setting 15 is double zeros everywhere. The only change is number 12. You set it up to 90%. 90% is the highest value that the machine will accept. So at this moment, this unit will only use the batteries up to 90% and then will automatically kick back to Eskom so that you still have 90% of your battery left. Then as well, you should always remember that your inverter use 3 volts above this EOD setting, your on-grid EOD setting. So let's say, for instance, you tell the inverter at 46 volts, you go back to grid power, you can't use my batteries anymore. Only at 49 volts, the inverter will start to use your battery power again, even if there's sufficient solar power. So it will charge your batteries with all available solar power up till 43 volts before it will start to use some of your battery power to supply the loads again if Eskom is available. Once Eskom is not available anymore, then it will go to setting 11, that's your cutoff setting. Then the last working mode that a lot of clients would like to have is a backup system. That means there's no panels, it's only a battery inverter just to supply the load during load shedding. You go into your settings. We run all the way to setting number 11. 11 we start, you put on 20% or whatever cutoff. EOD the same at 90%. Then setting 14, this is your AC charge. Setting, we enable AC charge. Then your AC charge we put at the start value, 0000. Then okay, then from there on we put it to the AC charge to type. The RI in was AC in, so that means it will permanently charge your batteries. This is only on the newest firmwares that you'll see this option here. If the machine wasn't updated, it will just basically go into AC charge. Then it will be AC charge enabled. Then your start time will be P1 start, 0000. Then P1 end will be 23:59. Then the rest of the P values you can keep 00 because you told the machine on the first time now it should basically charge your batteries 24/7. So every day, 24 hours during the day, this machine will keep your batteries full from Eskom, and that's how you set it. Setting number 15, you can also double set it. P1 start 00 and P1 end. You put to 23:59 and you press enter through all the other values to set them to double zeros. And then your machine is basically set up for a backup unit. That's that on the settings wise for working modes. Then the last setting that you'll really use on the on-screen setting is setting number 21. And setting number 21 is our parallel option setting. So from here on, you can decide 1 pH, and then you can't change the phase. And then the last option is battery shared, disabled. So I'm just going to go back on this one. Then you can also choose 3-phase on this one to say it's a 3-phase system. And as soon as it's in a 3-phase system, you can choose your phases, which inverter is which phase. But for this moment, I'm going to have to select no parallel because it's only one unit. and then you'll see your unit will restart once you've entered this setting. That's on your working modes for this inverter at the moment. So if you work from the manual, you'll fairly have almost all your working modes that you can get from this inverter at this moment. So that's for the settings on the working mode wise. The only other settings that you're really going to work with is setting number 2 is your panels. That's where you can decide which input is on your panels. So that means one MPPT. Okay, let's start with this one. It will be usually on the setting from the out of the factory. That's one of the two lines that means your two MPPTs is running separately. That's for the DC source, and that is for the parallel one. So that means that you can use your two MPPTs as one MPPT. You're physically going to have to parallel your two positives and your two negatives with a wire, and then you can use the MPPT as one MPPT running 26 amps and not 13 amps anymore. So that's that on the setting number 2. So let's put it to that setting. Then setting number 3 is your battery setting. So on setting number 3, you can see here your type is flashing. So once your type is flashing, you will be able to select lithium, no battery, or lead acid. But I have a lithium battery here. Then you select your battery brand. Your battery brand is in your booklet that you get with the inverter. I think for 6 of the types of the batteries, but the rest of them are well on your monitoring page. When you go to maintain, you can see every number there, which numbers is for which batteries. I'm on number 8 because I have a Dynas battery of this inverter for today. So as long as you press, then you'll see your inverter will restart. Now, you always have to do setting 3 first. All your settings resets after you've changed something on setting 3. So at this moment, all my settings that I've done with you guys will be automatically reset to factory settings. So if I want a specific work mode, I'm going to have to run through all my settings again. So firstly, if you get an inverter, set up your battery setting number 3 before you do any other settings. So for instance, let's go to setting number 6. Setting number 6 is your charge setting. So that's for your maximum charge that you can enter in this unit. So let's say this battery doesn't allow me to charge more than 40 amps, but I don't like to charge my battery there. I believe you should only charge at 20 amps. And you can enter the 20 amps. Then the second one is your AC charge, 20 amps. And the last one is your generator charge, 20 amps as well. And then I've done my AC charge settings as well. Then from there on, you'll see 7 and 8 is only applicable for a system that's using lead acid batteries. So if you're not using lead acid batteries, you can't use 7 or 8. The machine won't allow you to change it because the battery is communicating, so it's not applicable. Then setting 9 is my total discharge. So for this battery I have here, let's say it's 50 amps. I may not use more than 50 amps of this battery at this moment, otherwise the battery BMS will trip out. And then at this value that you put in at the 50 amps, it's 50 amps DC current. Not 50 amps AC current, but it's 50 amps DC current. So 50 amps is going to give you roughly 2.5 kilowatts worth of DC power, just a rough estimate. So yes, remember my ampage values is in DC amps. The same on the AC charge, it is DC amps that's combined. So if you say 30 amps for AC charge, it means 30 amps on the DC side and not on the AC side. That's that on that settings, and that's basically most of the settings that you're really going to play with. The rest of the settings is minor stuff that 99% of the clients won't use on the display settings. Is there any questions on the display settings that anyone would like me to quickly run through on the display settings? Anything there? Okay, I see there's a question that I missed here that says difference between AC coupled inverters and hybrid inverter types. Is it only work with grid supply? Okay, so if I'm not mistaken, what you mean by an AC coupled inverter, do you mean like a grid tie inverter that takes your power from your PV panels and provides the just help to provide loads during the day? As I understand your question, what you'd like to know is with this unit, if the hybrid function is enabled or when it's feeding into the grid, is it only working when there's grid supply? If I understand your question correct, then yes. That function of the machine will always only work when there's grid supply. As soon as Eskom or your grid supply is not sufficient anymore, then this unit will stop using the Eskom and then we'll go to a backup mode. That means that only your essential side will be supplied, your output side. So the inverter will still function 100%. It just won't export power to the grid anymore, or your PV-AC function won't work because there's no grid power to make that function work. But the rest of the inverter will still work as normal, meaning your battery will supply the loads of your inverter. Just tell me if I understood your question correctly. Otherwise, just type a question in a slightly different manner so that I can maybe understand your question better if I did not understand it correctly. So anybody else here that has any other questions? This is a question and answer session today. So the training, I just went through a few small stuff and everything. Is there any other questions that any of you have on the installation side, spec sides, monitoring side, so that we can run through it to help you to get to know this machine much better at this moment? Okay. The SNAs will be approved by insurance companies if you have it in an off-grid type of scenario. It depends if your insurance companies wants a COC or so forth. The SNA is not an NRS approved machine because it's developed like all your expert machines, like all your Growatts and Kodaks, Mesas, all of them that uses the same board, your expert boards, your electronic boards. This machine is made to be the same as they are. Although that Luxpower isn't using their boards, it's Luxpower's own R&D board that they made. So this is a completely separate type of board. It's not a Voltronic board at all. It's an own developed board, but yeah, it depends on your insurance companies what they would like. If they would like a COC and stuff like that, then you're going to have to use a fully hybrid inverter that's NRS approved. If you have it on a farm where Eskom is not applicable or something like that, then they will cover it because then it's regulations. So it all depends on insurance companies what they would like on that one. Any other questions on this unit that we can cover for you guys? And then as well on the topic of the NRS approved, that mine of Luxpower's new 10 and 12 kilowatt units will be here soon. Mid-July, we'll have the first 10 kilowatt fully hybrid units in South Africa. So we are looking forward to producing the market of a 10 kilowatt unit single phase, and then as well as the 12 kilowatt single phase units that will be brought to South Africa. So the 10 is the first one to come. It will be mid-July. So hopefully in the next 2 to 3 weeks, we'll have our 10 kilowatt units here, and the 12s will be end July, August, around there. We'll have the first 12s, and they are in the process of doing the NRS approved certificates for them as well. So hopefully by the time they are in South Africa, we will have them fully NRS compliant, meaning that it will be on the list that you can install it in Cape Town, and Cape Town will be happy, and you can fully give it a COC on these units. As the off-grid unit will only stay for now in the 5 kilowatt one that you are seeing in front of you now. Is there any questions about the Luxpower SNA 5000 off-grid unit that the topics was about today? Or is everybody fairly satisfied with questions and stuff like that? Okay. I don't see that there's any questions. I'm gonna, okay. No, you can't give a COC for a SNA 5000 inverter. You can't give it for any off-grid inverter that's available on the market at this moment. None of your off-grid inverters is compliant with NRS regulations. We have stock of the LXPs. There is a lot of LXPs in South Africa available. So yes, we have of the LXPs. Unfortunately, if you'd like a COC, you're going to have to buy a more expensive hybrid inverters, like my Luxpower LXP. That's a fully hybrid inverter, NRS approved, can handle up to 8.5 kilowatts worth of panels. So it's also a fanless unit. So there's no fans on this unit. So you can basically put this unit above your bed and you won't hear it operate at all. It's a quiet unit, no fans at all. So it's a nice unit to put in a small house where the people don't like any fan noises. The LXP will work quite good in such instances. Fully IP65 rated unit, as well as a 5-year warranty on the LXPs. So the LXPs is a very nice unit, a very neat unit as well. Also have exactly the same monitoring page. We use the same monitoring page for all our units. And it has the same settings. You can also change all the settings remotely, monitor it remotely, and all of that stuff. Then lastly, before all of you go, if you don't have an installer's account, please ask your distributors that you buy from to create an installer's account for you, so that you have your own customer's code. It's very important that you have your own customer's code, so that you can monitor all the clients that you install systems, and they will also have their own monitoring side. If you create an end user's account, it will ask you for a customer's code. Now, if you don't have installer's account, you won't have it, but as soon as you have an installer's account, then you have your own customer's code. So please ask your distributors for a customer's code. It is very, very important to have your own customer's code. And you get your customer's codes once they've created an installer's account for you. And if your distributor can't create an installer's account for you, please contact me. I'm going to give my number at the end of this thing. Give me a WhatsApp with your email address, your business name, your name, and your cell phone number, and then I will create a installer's account for you with your own customer's code, so that you have the ability to create end users accounts and still monitor their systems as well. The SNA 5000 inverter is new to South Africa, but it wasn't developed specially for South Africa now. But we brought it to South Africa for reason being is we know our off-grid market that was mainly run by your Voltronic units and your expert boards. We had a lot of complaints on these units, and we saw a big gap in the South African market for a very good quality off-grid unit that has 2 MPPT inputs, that has monitoring functions so that you can monitor it easily, that you can do your settings remotely, don't have to be on the machine and stuff like that. So that's why we brought the SNA 5000 to South Africa, because we saw that this unit can work very well in the South African market at this moment. And at this moment, it is doing very well in South Africa. We are very pleased with the total amount of inverters that's been sold versus the amount of inverters that's been sent back. We have extremely low return rate at this moment. So we are very proud of these inverters, and we have a lot of confidence in these inverters at this moment. They are doing very, very well in the South African market. Um, if that answers your question. This unit is sold around the world. So it's not a dedicated South African unit. It's a worldwide used unit at this moment. There's a few countries that this unit is being used at this moment. For instance, we are giving it to there's a few countries up in South Africa and stuff that also uses this unit. And then one new place that we're looking at is like Vietnam is also going to use this unit. So we are using this unit across the world. That's why we have all the we have a lot of units running all around the world, and we are fairly happy with the performance of this unit, and we trust it very well. We have a lot of trust in this unit as well. So yes, I hope that answers your question. Is there anything else that you guys would like to answer questions? As soon as there's no questions, really, I'm going to end this meeting, but I'm going to give my number here. Feel free to WhatsApp me on this number. Then I'll try to respond as soon as possible to you on this number, and then I'll create an account. If you don't have an installer's account and your distributor can't create it for you, feel free to WhatsApp me, and then I'll definitely create you an account, and we'll get you ready and set up to have the right account and the right access so that you can give the support to your clients. And then that's it. Any other questions of anybody? I'm going to give about 30 seconds plus for somebody just to quickly type and answer. And if there's nothing, I'm going to post my numbers along there. So you can WhatsApp me there. Is there any questions you can ask? If there's questions that we missed during the seminar, please WhatsApp it to me. I'll then personally answer you as well on that number. So I think that it looks like that there's nobody else that answered. So have a lovely day, and thank you for joining this meeting.
Thank you, Jacob. Thank you. Bye-bye.